Okay, we're going on to chapter 4, and we're getting into a lot of graphing. But the first thing we want to learn about is proportional relationships. So we are going to look at direct proportions. And we have some formulas down here for direct proportion. Y equals kx, where k stands for a constant. And another way you could write it is y divided by x equals k. But we generally don't see this second way. You are generally used to seeing it this way because it looks like y equals mx plus b, something you would have learned about last year. A direct proportion means as one value goes up, so does the other. So for example here, we're going to talk about buying stuff. At a local farm stand, 6 apples can be bought for $4. Determine how much it will cost to buy a dozen. So, see, the more apples I buy, the higher the price here. This is a direct proportion. So we could set up something you're used to doing probably from 6th grade. 6 apples is to $4. As a dozen apples is to, well, we don't know how many dollars that is. So you can do this quite quickly. You could see that, oh, this 6 right here must have been multiplied by 2. That's how I got to 12. So I'm going to do the same thing down here to keep my fraction balanced. I'll multiply the bottom by 2 also. So we figured that x was $8. It would cost me $8 to buy a dozen apples based on this price. So how about 20 apples? Well, we'll just set up a proportion again. 6 is to 4 as 20 is to what? And I'm going to come over here, and I always put my labels so I know what is what. So I put apples over money. So over here I have to put apples over money. Now 6 times nothing that we know gets me 20. So I'm going to do what we called last year cross multiplying. Mrs. Senlensky might have called it crossed swords. So basically what I do is I start here with my 6 times x gets me 6x. 20 times 4 gets me 80. And then basically I'm dividing by 6 to figure out, well, how much is x right there? Let's see, 80 divided by 6 is 13.33 repeating, but since I'm dealing with money, it's $13.33. Now another way to represent this is by graphing. So we've got a couple of things we have. We have a grid over here, but we have to label our grid, what these axes mean for us. In other words, here's my x-axis and here's my y-axis. So I have to label what x and y mean. Well, see, the cost depends on the number of apples we bought. So the independent variable, the x, is the number of apples. And then over here, this is the cost. And I'm going to add a little dollar sign here because we are spending in dollars. So I had to show that this is the cost in dollars, that this isn't 5 cents and 10 cents, that this is actually dollars. All right, so we're going to graph this right now. C is the total cost of the apples, and N is the number of apples that we bought. So C is the dependent variable. My cost depends on how many apples I bought. So if we go back to the first page, we can get 2 points very easily that go on this graph. Number of apples bought and their cost. Well, the first one they gave us was 6 apples, cost $4. Six apples cost $4. Then we figured out how much a dozen apples cost. A dozen apples cost $8. So a dozen apples cost us $8. So now if I go to graph this, I'm going to use apples as my points. I'm going to go over to 6 apples, and it cost us $4. And then 12 apples cost us $8. Now obviously, the easiest point to graph is 0, 0. Because if we buy no apples, come on, get over there, it costs us no money. So that's one of the things with direct proportions. It always goes through 0, 0. Now, I could draw a line and connect these apples, but that really wouldn't make sense in this case. Because by drawing this line, I'm saying that I can buy any amount of apples from 0 to 12 and beyond. So that means I can go to a farm stand and ask for 1.5 apples? No, that's ridiculous. We can only buy in whole apples. So technically, we really shouldn't draw a line to connect these apples. We should figure out what's called the unit cost per apples. How much does one apple cost? Well, once again, if 6 apples cost $4, 6 apples, $4, I am going to divide 6 by 6 to figure out how much one apple is. That's why I divided this, because this represents apples. I want to know how much one apple is. So that means I have to do 4 divided by 6. And that comes out to 0.6666, repeating, which is really 67 cents. So we're finding out that each apple is about 67 cents.
All right, so the next example, we have Jenny here, who can run 5 meters in 2 seconds. So which of these choices, 1, 2, 3, or 4, shows that she's going at the same constant rate? Well, she's going 5 meters for every 2 seconds. So I should be looking for 5 over 2 somewhere. So for example, her distance, if we wanted to figure out her distance, we would take her rate and multiply it. Let's say she ran for 4 seconds. Then she would have gone 10 meters. And it makes sense because she's going 5 meters per 2 seconds. So if she went for 4 seconds, we double it, we get 10. So which one of these is showing me her distance is 5/2? Distance is 2/5, no. Distance is 5 times no. Distance is 2, here it is right here. Her distance is her speed times as long as she runs. And if we look at it, that's right here. That is our direct proportion. Okay, we're going to do one more. Let's move this up a little bit over here. Erica is driving at a constant rate. She travels 120 miles in a span of 2 hours. So once again, I'm going to come over here and I'm going to write it as a rate, 120 miles per 2 hours. And I may want to make it into a unit rate, which means how far she go in 1 hour, which is very simple. if I were to divide this by 2 to get it down to 1, I'll divide this by 2, and that would get me down to 60 miles per hour. So if she's traveling at the same rate, how far will she travel in 3 hours? Well, right here, it's telling us that she travels 60 miles for every 1 hour. So if she's going for 3 hours, 60 times 3, she's going 180 miles. How much will time take her to travel 150 miles? All right, well, that's a little different. She goes 60 miles per 1 hour. Well, if she travels 2 hours, we already know she's going 120. But now 150, that's 30 extra miles. Well, 30 is half of 60. So half of an hour is a half hour. So it must take her 2.5 hours to go 150 miles. Or if we looked at it in terms of writing it as a direct proportion, y is some constant times k. Well, my constant is 60 miles per hour. And that gets my distance. So now if I were to just put 50 in here, 150, sorry, and solved it, h is 150 divided by 60. The zeros cancel out. 3 goes in there twice. 3 goes in there 5. 5 divided by 2 is 2.5. So there's 2.5 hours. So there's a couple of different ways you can do it. You can do it as a unit rate, or you can do it as common sense. All right. Okay, the last thing I want to do is graph this. So her distance is found by taking her unit rate and multiplying by how many hours she drives. That is the proportional relationship between distance and the time that she travels. So here they wanted me to use t, so I'm going to come in here and I'm going to change that h to a t because they said use t. So basically this just means if we go to graph this, if we look at our chart, here's t for time, here's d for distance. If I don't travel any time, I obviously don't go any distance. If I travel 1 hour, I go 60 miles. If I travel 2 hours, well, they told me 2 hours, I go 120 miles. If I go for 3 hours, I go 180. So if I go to graph these, it's very simple. 1 hour, 20, 40, I can go 60 miles. 2 hours, I can go 120, 20, 40, 60, 80, 100, 120. In 3 hours, I can go 180. 140, 160, 180. And I will connect these with a straight line. And there is my graph.